Now coming to the next chapter, that is biomolecules. Biomolecules, so to say. Now, in biomolecules, we are going to study about carbohydrates. Now, what are carbohydrates? Now, before going to the definition, just let me tell you in what I can say, explain you what is carbohydrates. Carbohydrates are naturally occurring organic compounds of carbon, hydrogen, and oxygen. You got it? Naturally occurring organic compounds of carbon, hydrogen, oxygen. Carbohydrate. Hydrate means hydrogen, oxygen, and carbo means carbon. We can say that. And may be regarded as one of the most important classes of biomolecules. Carbohydrates. Fine. Now, carbohydrates are composed of carbon, hydrogen, oxygen. Already I said it. Now, if you see the formula of carbohydrates, its general formula is there is CxH2O whole Y. Now, how can we say this? It is CxH2O whole Y, the general formula of carbohydrates. For example, C6H12O6. It's a formula of glucose. So, I can write it as CxH2O whole 6. We can say that Cx, here x is what? 6, we can say that. Clear? So in this way, what you find is that it has its general formula is CxH2O whole Y. Alright, here that is in case of carbohydrate, the hydrogen and oxygen are present in the ratio 2:1. You can see hydrogen and oxygen present in the ratio 2:1, just like water. For that reason, I wrote this formula. So its general formula is this. So hence we got it. That is C6H12O6 can be written in this way also. Got it? Just an example I've given you to explain the nature of carbohydrates. We can say that. Clear? Now, next is, in fact, in carbohydrates, it contains aldehyde group. It may contain keto group. And also, what you find is that it may contain also the OH group, the hydroxyl group. Alright? In carbohydrates, it may contain aldehyde group or a keto group, apart from H and OH group which is being present. Clear? In carbohydrates, so to say. Now, carbohydrates for that reason, now coming to the definition, carbohydrates for that reasons are polyhydroxyaldehydes or polyhydroxyketones. We can say that. Polyhydroxyaldehydes or polyhydroxyketones of large polymeric molecules it is. Alright, it's a large polymeric molecules which upon hydrolysis yields polyhydroxyaldehydes and polyhydroxyketones, we can say that. So we can say carbohydrates are polyhydroxyaldehydes or polyhydroxyketones. We can say, I said you, it may contain aldehyde group or it may contain ketone group. For example, if it contain aldehyde group, we call it as aldoses, those carbohydrates as. And if it contain the ketone group, we call it as ketoses. We can say that. Clear? So in this way, they are large polymeric aldehydes and ketones which upon hydrolysis gives polyhydroxyaldehydes and polyhydroxyketones. Now, based upon the behavior of hydrolysis, we are having carbohydrates, monosaccharides, then oligosaccharides, then polysaccharides, so to say, based upon the phenomena of hydrolysis. Alright? On the basis of the behavior of hydrolysis. Now, monosaccharides means monosaccharides are those polyhydroxyaldehydes or polyhydroxyketones which cannot be decomposed further by hydrolysis to give simple carbohydrates. Means upon hydrolysis we cannot get further simpler carbohydrates, will not get it. They are those polyhydroxyaldehydes and ketones which upon hydrolysis further does not give you further simpler carbohydrates or further simpler ketones, you will not be getting it. Alright, means further simpler aldoses or ketoses, you will not be getting it, so to say. So, what is the general formula it is? It is nothing but CH2O whole N, where N is equal to 1, 2, 3, 4, 5, 6, and this way you will be getting it. Generally, the N value of N ranges from 3 to 7, we can say that. CH2O whole N, we can say. Clear? So, the example is, we can say glucose, which formula is C6H12O6. Fructose, whose formula is also C6H12O6. Alright, we can say that. The difference between glucose and fructose is, we'll study it later on, that what is the difference between glucose and fructose. Otherwise, they have got the same molecular formula, that is C6H12 O6, glucose and fructose. Galactose is also C6H12O6. Even ribose, which is another what you can say monosaccharide, C6H10O5, we can say that. Clear? So in this way, these are the different monosaccharides, so to say, we are having. Got it? It is known as simple sugar. Upon hydrolysis, we cannot get further simpler sugar, we can say that. Next, we will be coming oligosaccharides. Under oligosaccharides, we are having disaccharides, trisaccharides, tetrasaccharides, pentasaccharides. In this way, we will be having it. The carbohydrates which upon hydrolysis yields 2 units of the same or different monosaccharides are called disaccharides. 2 or we can say give 2 or units of the same or different monosaccharides. 2 units of the same saccharides or 2 units of the different saccharides, we can say that, are known as oligosaccharides. We can say that. Clear? That is disaccharide. Sorry, I am saying it is disaccharide. 2 units I am saying. So it is disaccharide. Example of disaccharide is your sucrose, then maltose, then lactose. We can say that they come under that is disaccharides whose molecular formula is C12H22O11. Molecular formula is C12H22O11, we can say. Similarly, we have got trisaccharides, carbohydrates which upon hydrolysis furnish 3 units of the same or different monosaccharides are called trisaccharides. 3 units of the same or different trisaccharides. They are called as of the monosaccharides are known as trisaccharides, so to say, we can say that. That is raffinose, we can say C18H32O16. C18H32O16. Here you see, if you see it here, the previous example I gave you C12H22O11, isn't it? Previously I gave you C6H12O6. Then this is your mono. Alright, then I said C12H22O11. This is your di. Then I said C18. Alright, that is your raffinose. That is nothing but C18. What is that? H32. Always oxygen is to hydrogen is nothing but 1:2. Oxygen is to hydrogen. You can see here. In all the cases, it is nothing but it is 1:2. This is mono, rather I should write. Okay, this is your trisaccharide. So here you can see 6, then 12, then 18. It is increasing by 6. Alright, it is increasing by 6. 6, see 6, 6, C12, C18, increasing by 6. Here it is 12, then 10 increased 22, and it is 32. 10, 10 it is increasing. Then it is 6, then it is 11, and it is, that is nothing but 16, we can say that. Again it is increasing by 5, we can say. Because if it is increasing by 10, this will increase by 5. Isn't it? 2:1 ratio. Clear? So in this way you can remember it. This is the trick I am saying to remember it. Alright. So similarly, tetrasaccharides example is your stachyros. Tetrasaccharides example is your stachyros. Now can you tell me the formula of stachyros based upon this? 6 I will increase. It will be how much? C24. 18 plus H24. Here 10 I will increase, but it will be H42. And O will be how much? Half of that. That is nothing but 21. So in this way you can remember it. That is your stachyros. We can say that. Clear? Fine. So it is coming under tetrasaccharides. This is mono, di, tri, and this is your tetrasaccharides, which is stachyros. Similarly, now this stachyros only, or this raffinose, or this will hydrolysis upon this disaccharide, trisaccharides, tetrasaccharides upon hydrolysis will give you what? Simple sugar. It will give you what? Monosaccharides upon hydrolysis. But monosaccharides upon hydrolysis will not give you further simpler sugar. That is, you need to remember it. Now polysaccharides, carbohydrates which upon hydrolysis gives a large number of monosaccharide molecules are called polysaccharides. Which upon hydrolysis gives large number of monosaccharide molecules. They are called as polysaccharides. Example, starch, cellulose, glycogen, etc. They are coming under polysaccharides, so to say. So that is, these are the different types of what you can say saccharides or carbohydrates based upon hydrolysis. We can say that. Clear? Now next time that is your classification of that is sugar on the basis of its taste. Now we are having that is sweet sugar and non-sweet sugar. From the name itself it says carbohydrates which are sweet in taste are called sugars. Alright? And the carbohydrates which are not sweet in taste are called non-sugar. They are non-sweet sugar, we can say that. They are non-sugars. So the one which is sweet sugar, which is sweet in taste, is nothing but glucose, fructose, sucrose, lactose, galactose, etc. They come under this category, which are sweet in nature. Got it? Clear? Now, that's non-sweet sugar is your polysaccharides. All the polysaccharides, you can say that is starch, cellulose, glycogen. They are coming under non-sugar or non-sweet sugar. We can say that. Clear? That is starch, cellulose, etc. And some common examples are of non-sugar. We can say that. Clear? Now, next is your reducing sugar and non-reducing sugar. The carbohydrates which are capable of reducing Tollens reagent and Fehling solution are called reducing sugar. Means they will react with Tollens reagent, they will react with Fehling solution. Which one? That is reducing sugar, we can say that. So hence they will reduce because they are the what you can say oxidizing agent, isn't it? The Tollens reagent or the Fehling solution. So hence all monosaccharides and disaccharides except sucrose are reducing sugar. All monosaccharides and disaccharides except sucrose, you can note it down this point, are coming under reducing sugar. Alright, non-reducing sugar are the carbohydrates which are unable to reduce Tollens reagent or Fehling solution are called non-reducing sugar. Sucrose is a non-reducing sugar, so to say. Sucrose, it does not reduce. Sucrose is a non-reducing sugar, so to say. We can say that. Clear? So, in this way, we are having that is your non-reducing sugar and reducing sugar. Reducing sugar will reduce Tollens reagent and Fehling solution. Non-reducing sugar will not reduce Tollens reagent or the Fehling solution, so to say. We can say. Now, based upon the nature, we have got already, that is based upon the group which is attached to, that is carbon atom, clear, that is apart from H and OH group, which is of course there, we are having aldoses and ketoses. Already I have said you earlier only, aldoses means monosaccharides having aldehyde group as a functional group, and monosaccharides having ketone as a functional group are known as ketoses, so to say. Clear? If it contains ketone, that is C double bond O group, it is called as ketosis, and if it contains CHO, then it is said to be as aldoses, so to say. So, depending upon the number of carbon atoms present, monosaccharides may be further classified as trioses, tetrahouses, penthouses, hexahouses, etc. Trioses means having 3 carbon atoms present in it. Tetrahouses means, you can come to know, 4 carbon atoms present in it. Penthouses means having 5 carbon atoms present in it. Hexahouses means having 6 carbon atoms present in it. That is depending upon the number of carbon atoms present. Monosaccharides are further classified as in this way: trioses, tetrahouses, penthouses, hexahouses. From the name itself, we can come to know that how many carbon atoms is being present, so to say. Now, next is after that the trioses. What is the example we can give it? Like we can give the example of trioses is your glyceraldehyde. It is an aldehyde. Name itself it says glyceraldehyde. So what will be the formula of glyceraldehyde? Glyceraldehyde, CHO, CHOH, single bond CH2OH. This is your glyceraldehyde. See, aldehyde group. Similarly, if I say dihydroxyacetone, we can say that dihydroxyacetone. Dihydroxyacetone, what is the formula? Dihydroxy, isn't it? Acetone means C double bond O, and dihydroxy means having 2 OH group present in it. See, what is the formula of acetone? Acetone is CH3COCH3. Acetone is CH3COCH3. So, instead of one H, I have replaced it by OH. Here also, instead of one H, I have replaced it by OH. So, what you got? Dihydroxyacetone. In this way, over. This is dihydroxyacetone, so to say. Clear? So, this is coming under what? Ketosis. Alright, now, the examples. So, in this way, this is nothing but known as trioses. See, this is your glyceraldehyde and this is your dihydroxyacetone. This is your aldoses, this is your ketosis, because you can see a ketone group is there, and here you can see aldehyde group is there. Clear? In this way, we are having what you can say, if OH is on the what you can say, here it is on the right side. Here the OH, here if it is on the right side, it is said to be as D-glyceraldehyde. This does not stand for dextro. No. Here it is, D means dextrose, D family and L family. So it is known as not dextro, we can say that. Clear? So in this way, what you find is that if OH is on the left side, it is known as L family, L-glyceraldehyde. Again I repeat, here you can see OH is here on the right. Alright, here I can write it in this way, OH and here H. So this is your D-glyceraldehyde, this one, this compound is D-glyceraldehyde. D, capital D, not small d. Small d is your dextro. Here capital D means D family, we can say that. And if OH is on the left and H is on the right, we can say it is known as what? L, capital L. L stands for the L family, we can say that. Got it? L glyceraldehyde, so to say. It has nothing to do with dextro and levo. It has nothing to do with, let me say you, it has nothing to do with dextro that is on the right and the levo on the left. No, it has nothing to do with that. It is called as, that is compared to this CH2H from this group. Actually D and L, how do we define? If suppose compared to this CH2H, if OH is on the left, then it is said to be as L. Compared to this CH2H, if OH is on the right, this is said to be as D, capital D. In any, like this is, I have taken trihouses, in tetrahouses, pentahouses, hexahouses, and anything. Alright, how do we define capital D and capital L? That I am saying. Compared to this CH2H, compared to this CH2H, this CH2H. If this OH is on the left side, the first, after the CH2H, this OH is on the left side, it is said to be as L family. And if this OH is on the right side, it is said to be as D family, so to say. Got it? In this way, we are defining D and L family, so to say. We can say that. Clear? D glyceraldehyde and L glyceraldehyde, so to say. We can say that. Similarly, so that is same thing in hexoses also, pentoses also, and that is your, what you can say, that is your hexoses, pentoses, tetrahouses, anything. Let me take the example of hexoses, because that is what we are concerned of in this particular chapter. That is your glucose and fructose we are concerned of. Let us see that. So first let me write 6 carbon atoms, because hexoses, no? 1, 2, 3, 4, 5, 6. Now this is your CH2H. If OH I am writing on the right, see here. Alright, so this is known as D. Done. If OH is on the left, it is known as L. That's it. Clear. So now it is H, this is OH, this is OH, alternately I am writing it, H, and this is H, this is OH, and this is your CHO. So this is what? It is a glucose. It is a formula of glucose. C6H12O6, you can see that. It's a formula of glucose, you can say that. D or plus sign also we put it. That is glucose. Now this OH, if it is writing on the left, then it is L-glucose, we can say that. Clear? Now next is, what is the formula of fructose? What is the formula of fructose? We can say that. See here. So fructose also is hexoses, same thing, 6 carbon atoms, we'll take it here, 1, 2, 3, 4, 5, 6. Here it is CH2OH, and here I'll put first CH2OH. Then here it is OH, this is also D, I am writing it as, see, this is also D. Alright, here for fructose C double bond O will be there. For glucose we are having aldehyde group, for fructose we are having the ketone group, we can say that. Then it is here H, here OH, here it is O, that is your H, and this is OH. Here also you can say that it will be your H, and here it is your OH, we can say. See, so this is, in this way we got it. This one is D fructose, or we can put the plus sign also, we can say plus sign, either D or we can put the plus sign. Got it? Anything you can write it down in this way, D glucose or D fructose, we can say that. So now next is, we'll come to the cyclic structure. Cyclic structure. Now how do we get the cyclic structure? That is the formation of an intramolecular, within the molecule, that's called intra. Formation of an intramolecular hemiacetal or hemiketal. Now this hemiacetal, hemiketal, where you studied in aldehyde and ketone chapter. In aldehyde and ketone chapter, that is when an aldehyde reacts with an alcohol. Remember it, when an aldehyde reacts with an alcohol, then you get an hemiacetal, so to say. When aldehyde reacts with an alcohol, so I can say you the general formula is, here it is COH, here it is OR, and here it is H, and here any alkyl group we can say that. So this is known as what? Hemiacetal. How do we get it? When an aldehyde reacts with an alcohol, so to say. This is called as hemiacetal. Now, if another what you can say alcohol reacts with it, then what you will be getting it? Here OH will be replaced by your R. So OR you will be getting it. That is called as acetal. When another alcohol reacts with it, with hemi means what? Half. Hemi, semi, that's half. Got it? So in this way, when one OH is replaced by OR, that is said to be as hemiacetal. If one OH. Now this is your hemiacetal. But if both the OH is replaced by OR, means R, we can say that, both the OH, then it is said to be as what? Acetal. Now this is a formula of acetal. So here what I said, similarly ketal also we get it in this same way. Ketal also hemiketal. How do we get hemiketal? Hemiketal we get it in this manner. That is Rc. Let us say here it is OH, here it is R dash, and here it is, that is nothing but, we can say H, or what we will say is that RCOR dash, and here another alkyl group also we can take it, no problem. R or R dash, any alkyl group. Either you can take here R or you can take R dash. Same alkyl group we can take this. What is that? It is known as your hemiketal. That's it here. Hemiketal. It is known as. Now if you want only ketal, then what will I do? Very simple. This H will be replaced by another R or R dash. Anything. That is known as what? Ketal. This is known as ketal. Previously the formula which I wrote, that is your hemiketal. How do we get it? This hemiketal or hemiacetal. Already I studied. When alcohol reacts with aldehyde, we get hemiacetal. Similarly, when ketone reacts with alcohol, what we get? We get hemiketal. Followed? That is what I am saying. So, the formation of an intramolecular hemiacetal or hemiketal in a monosaccharide, got it? In a monosaccharide molecule results in a 5-membered or a 6-membered, what you can say, cyclic ring structure. 5-membered or 6-membered cyclic ring structure. The 5-membered ring structure contains 4 carbon atoms and an oxygen. Contains 4 carbon atoms and an oxygen, and is called its furanose form. Furanose. F-U-R-A-N-O-S-E. It is known as what? Furanose. F-U-R-A-N-O-S-E. Furanose form. 4 carbon atoms and 1 oxygen. Means it is in this way. 4 carbon atoms and 1 oxygen. Alright, like if I put it here, double bond, it is known as what? You have studied. It is a cyclic ether, which is otherwise called as what? Furan. F-U-R-A-N. Furan. Alright, furan, we can say that. Clear? But if there will be 5 carbon atoms and 1 oxygen, instead of 4 carbon atoms, if there will be 5 carbon atom, 1 oxygen, it is known as what? Pyranose. Pyranose structure. If 4 carbon atom, 1, 2, 3, 4, 4 carbon atom, 1 oxygen, it is called as furanose structure. If 5 carbon atom, 1, 2, 3, 4, 5, 5 carbon atom, 1 oxygen, it is known as what? Pyranose structure. Alright, in this way, we are getting the pyranose structure and the furanose structure, we can say that. Clear? The name of this compound is known as pyran and the name of the compound is known as furan, we can say that. Both are coming under cyclic ether. Cyclic ether. Ether has got 1 oxygen, so it is cyclic ether. We can say that. Clear? In this way, due to the intramolecular bonding, we can say that. Now, next is, that is the aqueous solution of glucose is dextrorotatory. That is why it is referred to as dextrose. Got it? The aqueous solution of glucose is dextrorotatory, and hence we call it as dextrose, we can say that. Now, how can we prepare glucose? How do we prepare glucose? We prepare glucose from sucrose. That is in the next video we will see. Thank you.